Many of you have taken physics and know what the relationship is between position, velocity, and acceleration. And one of the differences we're going to have is that you can actually have a negative position. Not always happening in physics, but if I have an x-axis, I can measure position in terms of a positive number to the right of the origin and a negative number to the left of the origin. An example of this is rolling a ball back and forth along the x-axis and have an equation like this, and you guys know that that has several zeros where that can cross over between the origin and come back and forth between left and right. So questions that will come up, and these are just kind of parts of questions, is just asking for a basic position, and that's just doing a t-chart of these different ones. So let's do that, because this entire page kind of deals with this. 0, 1, 2, and 7. When that would be most useful is, let's say that those are all possible candidates for extrema, and you have to determine through a candidates test which one's the furthest right and which one's the furthest left, especially if I give you a closed interval, which I'm not here. I'm just giving you these critical values for some reason or another. Think about the most efficient way to substitute those into the equation itself too. Mac, what's the optimal way to plug in values into this repeatedly? Well, if you plug in 0, you get 0. If you plug in 1, you get 1 minus 8 plus 10, which is 3. If I'm plugging in 2, I may now want to go to synthetic division. So I'm going to do it 1, negative 8, 10, and 0, and just set that up for 2 and 7. So if I do 2, and I do a lot of synthetic division where I just kind of do it in columns like this. So bring down the 1, 2 times 1 plus negative 8, 2 times negative 6 plus 10, which is negative 2, and then 2 times negative 2 plus 0, which is negative 4. So you get 2, negative 4, and then 7, you get 7 times 1 plus negative 8, 7 times negative 1 plus 10 is 3, and 7 times 3 plus 0 is 21, so 721. Now, that's all position. Velocity, you guys all know what velocity means. It's a rate of change of position, but velocity also has a direction about it. It's a vector quantity. Its direction could be positive, which means it's moving towards the positive x-axis, or negative. And if I do a velocity equation of v of t is equal to this quadratic, 3t squared minus 16t plus 10, finding the velocity of the ball at these different points is just a matter of doing another t-chart. 0, 1, 2, 7, and just doing some substitutions. 0 into that equation is going to give us 10. 1 is just going to be 3 minus 16 plus 10, which is negative 3. I still like my synthetic division, so plugging 2 and 7 in is going to be a matter of doing 3 times 2 plus negative 16, 2 times negative 10 plus 10, and that gives me negative 10. 7 times 3 plus negative 16, 7 times 5 plus 10 is 45. And the units on velocity should be in feet per second, whereas the units on position should just be in feet, and that's feet relative to the origin, or whatever you're defining as an origin. So we say velocity is a vector, it has direction and a magnitude. This word magnitude kind of goes back to that idea of absolute value, and we teach in basic numbers that every single integer has both a direction and a magnitude. This is something that's conceptually very difficult for students to grasp when I say that the number 7 actually represents plus 7, and its direction is 7, magnitude is 7, but its direction is positive, and that it's really made up of two components, because when we start doing things like this, 1 minus 5 plus 7 minus 2, I still get tons of students that want to change the minuses to plus negatives, especially depending on what middle school environment they come in, and they still kind of don't recognize that you're within the operation of addition, and you're just like signing which one's positive and negative in a very simplistic way. You guys mostly know speed is the absolute value of velocity, so strictly speaking, in a physics sense, if you use the word speed, you mean magnitude, and that's the thing there. And finally, acceleration is just a change in velocity. Magnitude. There you go. How quickly an object picks up or loses speed. Basically, that's a change in velocity over change in time. And its units tend to be things like feet per second squared or meters per second squared. It's also a vector. The big part of this is going to be you guys determining what's happening when you have positive negative velocities, positive negative accelerations happening at the same time. So for instance, the fact that a negative acceleration but a positive velocity means that the object is slowing down and will eventually change directions. That kind of thing then plays into original function, first derivative, and second derivative, because it's not just the rate of change, it's the rate of change, which is the concavity, and how that's playing out. So early examples of just things that we're going to do. Okay, this isn't even an early example. This is just basic acceleration. If this is an acceleration curve, we have time and acceleration relative to time of 0, 1, 2, and 7. This is also the same at those different points. A of t, a of 0 is negative 16. A of 1 would be 6 minus 16, or negative 10. I don't really need to do a synthetic division to plug in 2. 2 times 6 minus 16 is negative 4. And 7 times 6, 42 minus 16 is 26. And these units are all feet per second squared. Did any of you notice that every successive equation I was using was the derivative of the previous?
Yes.
So if I go up to look at the original one, this s of t, if I take a derivative of that, I get the equation for v of t. And if I take the derivative of v of t, I get the equation for a of t. They were all successive derivatives of each other. Yes, Colton?
Is there a reason why you have them in successive derivatives, or is that just like just for the fun of it?
I was using it to illustrate all the same problem, essentially. That was also the same reason I was using to pick the 4 same t points, just to show that at any point, given the original function, I can not only tell what's its position, I can tell its velocity and its acceleration, given only a position function. So this is the relationship that is pretty intuitive. Again, this is saying that acceleration is the second derivative of position, and velocity is the first derivative of position. And also that acceleration is the first derivative of velocity.
Wait a minute.
Mac wants to wait a
You
minute.
really want to?
Resume. We've done this distinction before in terminology between the instantaneous rate of change, which is the derivative, and the average rate of change, which is like a slope of an interval. To have an average rate of change or a slope over an interval, you need to know the endpoints of the interval. And it's any interval where the endpoints are not themselves.
Spell it
Oh, stop it. So, next example, a ball is rolled back and forth and you have a position function. Go ahead and tell me what the velocity and acceleration functions are.
Velocity is 3t squared minus 16t plus 10.
And acceleration?
6t minus 16.
Velocity t at 10. 300 minus 160
150.
plus 10. Yeah, it's 150. Units?
Meters per second.
Feet. I know, you hate feet because you've been trained to hate feet.
That's disgusting.
It's not disgusting.
It's so much worse to
Why?
write out.
Right.
Acceleration of 10?
It's 44.
Yeah. 44 feet per second squared. And the average velocity of the particle during the first 10 seconds. So to do average velocity during the first 10 seconds, you basically want to do s of 10 minus s of 0 over 10 minus 0. This is a slope.
15 feet per second.
So s of 10 was... Well, do we know what s of 10 is?
Yeah.
We can find out.
Oh, S of
Yeah.
10. Wait, isn't S of 10 just 150? No, that's V of 10. But isn't S the absolute value of 150?
Nope. S is position.
Oh, S
So I want to plug the position in. So if I plug t, this is 1,000 minus 800 plus 100. So
That's 300.
it's 300. S of 0 is 0 over 10 minus 0. And that's 30 feet per second. Believe it or not, I mean, the most common mistakes made with this are trying to do a derivative where it's asking for a process that doesn't require one. Okay, so not every equation I give you is going to be a polynomial. Polynomials are easy, they're very predictable. But the next one is the population of fruit flies in a test tube. There's a fruit fly story I can tell, but I'm going to wait till later. I know I took AP Bio and did fruit flies.
There's fruit flies in my house.
I have the wingless ones, so they're just ants.
So we have equation for the population of fruit flies. How many are originally in the test tube?
2.
P of 0 is 2. Find the average population growth in the first 4 days. So you want to do P of 0, which is 2, and P of 4, which is 22.
Yeah.
10 root 4 plus 2. When it says average population growth, do not start doing a derivative. This is just 22 minus 2 over 4 minus 0.
5
And that is 5 units.
flies per day.
Isn't it? Oh, yeah.
Find the average population growth in days 4 through 9. So really the only other added thing I need there is P of 9. Probably picking 9 because it's a perfect square, but that's 32. So then I have 32 minus 22 over 9 minus 5. No. Oh, sorry, over 9 minus... That's not minus 5, minus 4. That's 2 flies per day.
Cool.
And then how fast is the fruit fly population growing
Ooh, that's a drill.
at t of 9, or t equals 9? So for that we want p prime of 9. So I need to do p prime of t. Well, it can come back up and rewrite p of t equals 10 t to the 1/2 power plus 2. So then p prime of t is 5t to the negative 1/2, or 5 over root t.
5 over 3.
So p prime of 9 is 5/3 flies per diem. Diem is a Latin word that means day.
Cool, I take Latin. I'm
Cool.
not cultured.
I heard it helps so much on the SATs.
Okay, dynamite blast blows a wall straight up, or blows a rock straight up. So we're back to a polynomial. This is going to be a lot easier, but this is actually asking you to graph the position function. I'm gonna, if Uzi were here, I'd tell him like this is one case where I'm okay with the sketch because there's no real thing next to this, and the sketches are pretty much all going to be quadrant 1 graphs. And since it's a negative t squared, this is all going to be an inverted parabola. It just comes down to labeling your pieces. So labeling, setting your scale. Sorry, I didn't draw every eta.
Separately.
T's the act of X.
If I take this and factor it into 16t times 10 minus t, then I've got a firm grasp of what my zeros are. Zero and 10. Mrs. Manton would have taught you that halfway in between 0 and 10
Miss Man. It's
is
not
a
Mrs. Man.
vertex.
You're so wrong. Iris.
If I do s of 5, I get 16 times 5, 32, 64, 96,
Oh, that's an actor's name or something.
times 5, which is 100 times 5 minus 20, so 480. So this is kind of 5, 480. And that gives me a pretty solid sense. Oh, wait, is it 480? Is that right?
It's a great question.
500, yeah, that's 480. Find the velocity function. So v of t is equal to 160 minus 16t. A of t is equal to negative 16
Hey, we have 16.
t squared. Wait, negative 16t, right?
Six.
No, negative 32t. So this is negative 32. Speed of the rock after 8 seconds is v of 8. So 160 minus 32 times 8. 32 times 8 is 2 to the 5th times 2 to the 3rd, 2 to the 8th, 256. 160 minus 256.
84. Negative 84. It's alright.
It's not wrong.
90, I was going to say negative 96.
That'd be wrong.
160 minus 256.
Yeah.
Ah, you're right.
What's its direction?
Oh, it's going that way.
Negative. It's going
Down.
down, yeah.
That way.
Your x value here just is determining straight up and down. So your origin now moves like up and down, and the horizontal axis there was time. So this is just describing a rock that's just straight up and down. So
Would the speed be 96, not negative 96?
that's true. Speed, I guess, would be 96. We got to do a thing here, 96 feet per second. And that means down. So negative 96 is interpreted like this. Okay, find the velocity of the rock when it is 256 feet off the ground. So 256 feet off the ground, what do I really want to know at that point?
You want to know what V is if T is 250.
Nope, not T is 256.
S is 256.
S is 256. So I go 256 equals 160 T minus 16 T squared. And I want to figure out at what T that happens at.
Cool.
So everything divides by negative 16. So this is going to be T squared minus 10T plus 16 equals 0. Or T minus 2 and T minus 8 equals 0. Or this happens at T equals 2 and T equals 8, which would make sense that it's 256 feet off the ground at 2 positions. So if I go back to the graph, it's going to be something like this, intersecting at T equals 2 and T equals 8. So really I'm just looking for V of 2 and V of 8. Are they symmetrical?
Yeah.
Probably.
V of 2 is 160 minus 64, which is 96 feet per second. And then V of 8 is 160 minus... Oh, sorry, we already did that. V of 8 is negative 96 feet per second. So they are symmetrical.
Was the speed of rocket 96 feet per second?
Yeah, that's kind of been asked and answered.
Well, it's because you're talking
literally
about the
already had
absolute
that question.
values, magnitude.
We
like
did.
Speed versus velocity.
Well, it said speed of the rocket after 8 seconds.
Hey,
Oh, really?
what's
Yeah.
the speed of the rock at T equals 8?
After how many seconds does the rock hit the ground?
10,
Yeah, it's 10 seconds. Its roots are 10.
5,
Rock reaches a maximum height, 5 seconds.
488.
And the maximum height is 480.
Nope. We should just not do the last one.
Why would we not do the last one?
It's not worth it. Yeah.
Wait, what's the other? I missed all the other
We
answers.
don't want to learn it.
What's the...
You scroll up.
Huh?
Scroll up. I missed it. Little more. Alright.
These are all from the graph we just kind of assembled.
Oh, the average velocity is 0.
It is 0. If its position at S of 2, let's just kind of prove this. S of 2 would be, sorry, I need to go back up and look at the formula, 160T minus T squared.
Oh, it's just.
It's 2 and
So it's 320 minus 4. And, is this right?
Yeah. I don't know.
Oh, because
I
it's
just know that
symmetrical.
it's 0.
It's symmetrical.
And S of 8 is,
It's 0.
you guys aren't helping with S of 8.
Yay, no homework. Woo.
2 to the third, 128, 0, minus 64.
This student athlete wants you so funny.
Oh,
It's not 0.
Every single time. Yes, it is.
Yeah, it
Why
should
wouldn't
be.
it be
It should
zero?
be.
Because it's not. It's minus. It's subtract.
No, but it's
position's
average.
the same though.
But average velocity is.
But the
close.
Oh no,
Position.
yeah, it's velocity, not. Oh, it's
No,
velocity. Never
because
mind.
it's going straight up and then straight
It's
back down.
position though.
It's position.
Yeah.
I'm pausing.
You're
I'm making a
in
mistake.
position.
Found it. 16t squared.
That's what I said.
Well, you weren't saying it loud enough.
What?
Maybe you just couldn't hear Chilla's lame
So
headphones
it's 64, and then this is. You know what? Let's use the factored form. 60 t minus 69 t. So S of 2 is 32 times 8, and S of 8 is 128 times 2, 256, 256. So S of 8 minus S of 2 over 8 minus 2 is 0 over 6, or 0 feet per second.
You can just say total displacement over time.
I know, but you're trying to prove it. Okay, we're done.